Hello, everyone. Hello, Paris. Well, really happy to be here. My name is Alex Gluchowski. I'm from Matter Labs. I'm co-inventor of ZK Sync. And today we want to speak about rollups, Ethereum's rollup-centric roadmap. I want to begin by introducing ZK Stack and then talk a little bit more about how Ethereum-centric roadmap will look like, so we can imagine and see through problems and challenges. The ZK Stack is an initiative of ZK Sync project, which we announced recently. It's the opening of the source code of Era blockchain for everyone to be able to build their own custom rollups and custom hyperchains, more generically ZK-based chains. It's completely free, fully open source under MIT Apache license. It's EVM compatible. You can deploy any contracts that are written for Ethereum L1, and it's well battle tested because it's based on Era, and we'll talk about this more. It's modular, and you can customize different aspects of the stack for yourself. And the important thing is, Ethereum has many visions, and different people are coming to Ethereum with different ideas of what's the purpose of it, what we can build with it. ZK Sync started as a project focused on the mission of advancing freedom. We believe that one of the most important properties or purposes of blockchains is to make users sovereign and make the communication and transacting trustless. And this serves the idea of advancing freedom, which might be a bit hand-wavy. So recently, we published something we called ZK Credo. This is like a manifesto where we try to articulate exactly in a positive way what specifically this means. What are the properties of blockchains we want to preserve at high scale? And we came up with a list of points. It's still open for the community discussion. So it's on GitHub. You can engage in discussion, submit your proposals. But these are the things that have guided the development of ZK Sync from inception. Though this is kind of the end state, the vision where we want to arrive at the destination. But we have a second compass or North Star of how we actually prioritize these features. So one thing is what your final destination, the other thing is what actually do you do practically, step by step, in order to get there? What do we prioritize? For us, the priorities are based on the a user-centric approach to planning. We believe that you have to start with what users care about most for building your own rollup, or even if you're choosing a rollup or blockchain to deploy things on, what are going to be the properties that the users will get today, tomorrow, and then later that will determine what they actually want. This is the priority in which we are scheduling our things. We'll talk about security, liveness, UX, the cost, and then eventually the hyperscale, what it means for the broader picture. We'll start with security because it's non-negotiable. With blockchains, specifically with L2s, in layer 1s, you still have some way to correct problems. If you have a problem at L2, it can be detrimental. We see it with the bridging protocols that are being hacked and billions of dollars being lost. So we invested millions of dollars in audits and security contests to make sure that the construction of the ZK technology that we use is actually practically secure. ZK Rollup is, in theory, the only protocol that gives you 100% security derived from Ethereum, but in practice, it depends on how you actually implement it. So we invest heavily in this with a number of strong partners and a lot of independent researchers, and more are coming. But we also think about security as a continuous process with defense in-depth mindset. So one of your security layers can always fail. You want to have multiple layers that are independent, that rely on different independent mechanisms, such as 2FA, that you don't only rely on the cryptography, you also have layer of validation that ensures that transactions are secure, even if you have any problem in cryptography, which can be found later and fixed. We have introduced delayed withdrawals. All withdrawals are delayed by 24 hours in the initial phase of the project, so that we have time, the Security Council has time to intervene if something is going wrong. And there are more mechanisms this work. But this is the #1 non-negotiable priority for ZK Sync. The #2 priority is liveness, or more precisely, like reliability of liveness. If your protocol gets to produce huge reorgs quite frequently, it's not going to be a great experience for the end users, for whom transactions might be reverted and they won't be able to execute them, and for the applications, for builders, for other service providers on your blockchain. Liveness is critical. So ZK Sync, or the ZK Stack, basing on the source code of Era, is one of the most battle-tested stacks today. Like the Era, if you go to l2bit.info, you'll see that Era is actually the most actively used blockchain over the past 30 days. We are processing millions of transactions on average with something like around 10 TPS, close to 10 TPS. So the reliability of the protocol has been massively tested. The RPC, the infrastructure for requests, is also massively maintained. And we are actually investing a lot in making the protocol resilient with sufficient buffers, because 10 TPS is an average, but like we are actually capable of maintaining over 100 TPS, as shown by our load tests internally. And you want to be able to accommodate large spike in transactions. You don't want your protocol to be crashing on, like some NFT collection mint or some extraordinary events. You need this broad buffer. Even 100 TPS is not enough. We're going to be increasing that. It will go towards thousands, but like as a gradual process. The 10x buffer is something we consider sufficient. But liveness is one of the things that is requiring decentralization. Like if you rely on one provider, on one entity, on the centralized sequencer, you won't be able to guarantee the liveness for both technical reasons and potentially political and like organizational reasons or like security reasons. This is why we are decentralizing both Prover and the sequencer. I'll start with Prover. This week, we announced an upgrade of Era with a new proof system called Bujam. Today, it's the fastest ZK proof system in the world. We made the benchmarks with Stellar. We just made some more corrections, which makes it actually faster than Starkey. We will be updating that graph with Stellar. It's a Plonk-based proof system using Fry Starks, so it's fully transparent. And most importantly, our GPU implementation is optimized for consumer GPUs. So it only requires 6 GB of RAM. So it can be running on any cloud service, on the mining rigs, or even on home gaming computers. So this is the first step to decentralize the proofs, and we will follow up with the marketplace for proofs. On the sequencer side, we're working on a L2 consensus with a low latency for blocks under 1 second. We're using hot stuff, or a version of hot stuff called Hotshot. And which brings us to the next point, which is actually in the intersection of the user experience and liveness, because low latency is important for the users. Like waiting 15 seconds or maybe even longer to get your transaction through, it's not a great user experience. But it's not the only thing that matters. One interesting thing about Era that puts us aside from basically all the existing EVM L2s, or EVM-compatible, EVM-equivalent L2s, is native account abstraction. It's very similar to EAP 4337, except that it applies on ZK Stack or on Era to all accounts. It doesn't matter if your account is smart contract, which is primarily designed for like smart wallet accounts, or it's a EOA on MetaMask, or like basically any wallet is a smart contract in ZK Sync, and you can use native account abstraction features such as paying for gas in any token, or doing even gasless transactions, or implementing your own custom signature schemes, like signing with biometric devices from your smartphone. So like this is one of the things that that will be necessary for going broad into mass adoption. And finally, we have again, on the intersection of user experience and like performance properties of the protocol comes the question of the costs. Because if the transactions are expensive, users won't be able to afford it like to a broad degree, or some use cases will be just outpriced from the usage on the blockchain. I'm going to talk about the priorities. What like currently we are not the cheapest protocol in L2s, but it's going to change in the next weeks and months with the three things that are being rolled out. The first one is the data compression. This is what optimistic rollups currently already do, and it gives you roughly 60% off the cost. So like whenever you post something on chain on Ethereum, you can just post the full blob of data, like this is the update of the state from X to Y. But in most cases, you can compress it using Huffman coding, using exponential encoding of numbers, using dictionaries, using the IDs of accounts instead of full addresses. So like it's quite easy, like quite straightforward to implement. It's not specific to ZK Sync. We're just going to do it as everyone else. What is specific to the ZK stack, and what's really interesting, is that ZK Sync and Starknet are the only two protocols in the L2 world that use state diffs for data availability instead of call data. What this means is we publish not the transaction inputs, like the sequence transactions with like user, what function you're calling, from what account to what account with what signature. We collect the inputs, we execute the blocks, and we publish the final outcomes of the blocks. We only publish like what slots have in the storage have actually been affected by this block. And if you have like 1,000 transactions that only work with a few storage slots, and you can think of it as Oracle updates, just doing like 1,000 times, making a tick of Oracle updating the price, or 1,000 times arbitrage transaction with some AMM. You will, at the end of the block, only publish these few storage slots, which gives you a super linear compression of data. Not just a linear one with like some percentage, like 50, 60, 70%, but actually like 1,000x, 100, like 10,000% increase in throughput, or decrease in the price. So transactions like this are going to be a lot cheaper. Like Oracle updates are going to cost under 1 cent on the rollups, irrespective of the gas price on Ethereum, which is going to be really interesting for certain kinds of applications. But that is not enough, because normal transactions like NFTs or token transfers that affect normal, like ordinary accounts that are not tapping into the same storage slots over and over again are still going to be following the gas prices on Ethereum. And even after EAP 4844, that will give us probably 10x improvement, we still won't be able to handle lots that we see in the real world. Like if you think of all the value transactions in the world from payments, just payments alone are tens or hundreds of thousands of transactions per second across all the payment methods on the internet. You can't put them on Ethereum. They're just fundamentally, you cannot put something on a single monolithic blockchain of that scale. So you need some way to shard transactions indefinitely. And the feature that is coming to Era and ZK Stack in the near term is going to be the ZK Porter Volition. Volition is a protocol that allows you to extend your ZK rollup with optional different type of accounts called like Validium or ZK Porter accounts in our case, that keeps the data availability for these accounts off-chain. It's user choice where they want to hold their data and their assets. They reach users like liquidity providers in the protocols like Uniswap, Maker, Balancer, whatever, will probably prefer ZK Rollup because that gives you the same security guarantees as Ethereum. But retail users who can't afford to pay $1, $5, $10 for a transaction, or $50. Like at the peak, I think it was like several $100s for transacting on the DeFi protocols, will be able to do it from zk porter accounts, having native, instant, like, synchronous access to the protocols in the rollup, but still paying only a few cents per transaction. So I encourage you to take a look at the zk porter papers that we've published previously. This is something that is already core part of the zk stack and ERA architecture, and it's being unrolled. And bootjump was one of the things that was needed to be implemented before we can unroll this. And this finally brings us to a more interesting question. Like, would Volition be, like, is data availability extension into off-chain world, like with, with zk stack, it's modular, so you can use different data availability solutions for your chains. You can tap into EigenDA or Celestia or Avail or like whatever you want, or you can keep it, like if you're an enterprise builder, you can keep it to yourself with your own data availability committee. But that's not going to be enough, because the transactions on a single rollup, on a single chain, are still sequentially processed, and your sequencer is going to be the bottleneck. And when we talk about the hyperscale, what we mean is the ability to grow the network completely in an unlimited way. Like, think of the internet. If all of the servers, or like if all of the internet transactions had to happen on a single server, or even on a single data center, it would not be unlimited. It would not be able to grow like to millions and billions users and transactions and all the load that's happening there. You need something that can have like organic horizontal sharding capability. And this means we will need to have more chains. It's inevitable that the future is a multi-chain world. Like, there will be many rollups. Some rollups will be generic, some will be application-specific, but you can think of them, this is the metaphor I wanted to share for this talk, as city-states. Like, your users who have assets on-chain necessarily have to pick where they put these assets. You cannot abstract it away, because the assets can only live on one chain. So this is like, you have to pick where you live. You cannot live in two different cities. I mean, you can travel between them, but like at any given point of time, you are in one of the cities. And in this city, you will have different properties. Like, you have the law and culture governing the coexistence and living in this place, which is the ethos, values of the community of the chain, which is going to be different from community to community. You have the infrastructure, like, are the buildings new? Is everything working fine, or is everything broken? And you cannot move from one point of the city to another without a traffic jam that is defined by your tech stack. And a really important thing is then the opportunities. Like, if you live in something like New York City or Paris or another big megapolis, you have a lot of cool things around you, like shops and restaurants and services and so on. And if you live in a small city, then you're like, and also jobs where you can earn money, right? In a small city, the network effects are going to be much, much lower. So you need a really good reason why you would want to live in a small city. Like, maybe you are outpriced of the big one, then you could consider that. But like, if you don't have a job there, what you gonna do? But there is another interesting thing, like and this is what we see currently a spike of interest in, is the rise of the application-specific rollup. And if you think in city analogy, it's something like a Disneyland. It's a completely separate place. It's not easily accessible. You have to go there. It takes time and effort and cost to go there, but you're probably going to spend there an entire day. So you go there once, you stay there, you go to all the attractions, and then you go back. So like for something like Disney, it would totally make sense to make an application-specific chain, or like maybe it's a big exchange where you go and do a lot of trading and so on. But for a small thing like a single restaurant, it probably doesn't make as much sense. You know, like a few people might want to go there just to try it out because it's fancy, but most people won't be able to go like very far, like maybe take a flight to go to some shop far outside of the big city, right? So like the question is like, if you are a smaller application that serves specific niche, but is it justifiable for you to launch your own chain? Does it make sense or does it not make sense? Well, it depends on how far you're going to be, how expensive it's going to be for your users to get there from the place where they actually live, from the blockchain where they hold their assets. So let's see what it's determined by. The problem is the bridging is fundamentally broken. Like all the bridging we have today, except for native bridges on rollups, or like on like something like Ethereum, are broken, and we'll talk about why, or they are just expensive. Like if you want to transact from even one rollup on Ethereum to another one, you have to go through layer 1. You have to make a transaction on layer 1, so your bottleneck is going to be the throughput and the costs of the layer 1. And we know it's probably going to go up in price a lot with the surge of demand. So you could say like, well, we're just going to use the faster bridges between the rollups. The problem is they are fundamentally broken. They are not bridges. If you think of like a bridge, it's something that connects two pieces of land over the water. And what you would want, you have some assets on one island. You would want to just move them over the bridge to the other one so that the assets disappear on the first side and appear on the second side. Well, it's not how the bridges work today. Like the way they work is you kind of swim on the other side and you get an IOU, and someone holds the assets for you on the first side, and then you run around with this IOU, and like hopefully people trust you, and hopefully the other guys still keep your money there. Or like the alternative would be to keep piles of gold on both sides and try to manage them, which is like kind of again expensive, and someone has to do it, and you need capital requirements, and you cannot pass arbitrary messages this way, because when you pass arbitrary messages, there is no guarantee that you're going to be tapping into specific collateral that secures, like, is this message going to unlock like $1 or $1 billion? You don't know, because the complexity of the protocols that are being triggered by this message is unknown. You know, like it can be anything. So for arbitrary messages, you really need a native bridge, which is going to be expensive. And what you're going to do? So this is where ZK stack comes in with the, like, this is the key property of the ZK stack. This is really like why ZK stack was built in the first place. We're coming with this new primitive called hyperbridges, and the chains that you can build with ZK stack, we call them hyperchains, because they are connected with hyperbridges in a way like hyperlinks on the internet connect several pages. Like you can transact. You can, with hyperbridges, we use the power of zero-knowledge proofs to actually move assets, like burn them natively on one side and mint them natively on the other side. And it works. I don't have time to explain exactly how, but Kalman from our team had a talk today. You can rewatch it, or come to our stand, to our booth. We're going to be there in the next half an hour. We can answer questions technologically, and we have documentation about this publicly. But what you do is like you natively burn things, you send a message enforced by the validity proofs and verified by the validity proofs on the other chain. And since all the chains use these same circuits, they can blindly trust each other, which is not the property you have with any other technology but zero-knowledge proofs. So you really need ZK. ZK is key to be able to unlock the hyperbridges. And from the user perspective, it works seamlessly like sending an email. You can transact from any address on any chain, on any hyperchain. You sign one message, it sends arbitrary funds from this hyperchain to the other chain, along with the message. It can execute some logic there and send you the funds asynchronously, but relatively fast. Like I'm not going to lie and say it's going to be instant, but it's going to be like some seconds. Like the proving numbers we see suggest that it's going to be under 1 minute, like both ways, round trip. And so like one signature and you're going back. And this is how the Ethereum-centric rollup world will likely look like. You will end up, like this is our take on this future, you will see a couple of ecosystems that are tightly interconnected with very high proximity, with very low like barriers of connectivity between those chains. So you can have application-specific chains that are easy to access from the big chains like Era. And you will have other rollups which you then have to go through Ethereum, paying higher fees and taking longer delays into account. So like this is our vision, and happy to answer questions after that at the booth. Thank you, guys.